Hello, welcome. Let's try to solve another Leetcode problem 302, smallest rectangle enclosing black pixels. So for this problem, we are giving image. So inside this image, it's going to be 0 and 1. So for the string 0, it means it is a white cell, and for the string 1, it means a black cell. And let's just check the return. So yeah, the return gonna be the area of the smallest rectangle that encloses all black pixels. So let me make a drawing. Yeah. So yeah. So let's just check the rectangle. So here, so this is the black areas, and we are giving the image, and we are also giving a position which is gonna be a black pixel. So for example, it is a 0 and a 2. So this is okay. We are giving a 0, 2. And now we are going to find the smallest rectangle that is gonna enclose all the black pixels. So currently it's gonna be 6. Yeah, so for this rectangle, definitely it's gonna enclose all the black pixels, and it is the smallest. Yeah. So I think it's very obvious we're gonna have a brute force idea. It's gonna be the time complexity gonna be m times n. Yeah, because we just need to look through the image, and then we're gonna find yeah, what is the left position and what is the rightmost position. So the leftmost position, it is here, so it is at yeah, so it's gonna be the column, it's gonna be column 1, and the rightmost position is gonna be column 2. Yeah, and then we're gonna choose the top and bottom position. Yeah, similarly, so for the top and bottom. Yeah, so for the top position, so the most top position is going to be 0, and the most bottom position is going to be index 2, because this is row 0 and this is row 2. Yeah, now we just need to use the multiplication. So here going to be 0 minus 2 minus 0 plus 1 is going to be 3, and here it's going to be 2 minus 1 plus 1, it's going to be 2. So the final result is going to be 2 times 3, so it's going to be 6. Yeah, so this is just a O m times n and time complexity, but we need to find a solution which is going to be less than O m times n runtime complexity. But how can we do that? Yeah, so obviously we can directly use the DFS or BFS, because we are giving this x and y. Currently we didn't use this information. So if we use this information, I think this is okay. Yeah, because if we are using this information with x and y, it means the black cell, black pixel position, definitely the time complexity gonna be O black. So black means the number of black cells. So currently it is 4. So definitely this 4 is less than, yeah, less than m times n, which is gonna be 12. Yeah. So this is why yeah, this is the easiest way to solve the problem. Although there are some other hard ways, but currently let's just try the easy way to solve the problem. Definitely we're gonna use a time complexity gonna be less than, yeah, m times n. Yeah. So we're gonna define a function, and inside it's gonna be r and c. So this is gonna be the first position, x and y, the first position of the black pixels. Yeah. Now let me do some preparations. So I'm gonna prepare r and c. It's going to be length of the image and length of the image 0. So this is going to be the row and column of the image. And now we're going to prepare a directions. So inside it's going to be 0 1 1 0 and minus 1 0 and 0 minus 1. Yeah, so this is going to be the directions, and this is going to be the DFS function. Now, the first step is that we're gonna set this image with r and c to be 0 string. Yeah, because we're gonna run it by using the DFS. So first of all, we're gonna set it to 0. So this is a similar like a visited set. So I don't want to use a visited set. So I just want to set it as 0. So it means for the next time, I will not go back. I just loop through all of the black cells. Yeah. Now what I'm gonna do, I'm gonna check all the 4 directions, and I'm gonna update the new row and new column. Yeah. Now I want to check the boundary. So if everything is inside the boundary, yeah, and the image with this row and the column, if it is equal to 1. Yeah, so this means currently this one going to be a black cell. So if it is a black cell, I'm going to run the DFS with the new row and new column. Yeah, so first of all, I'm going to run the DFS with x and y, and finally I'm going to return the final result. But how can we get the final result? Yeah, we just need to check the most left border and most right border, most top border and most bottom border. Yeah, so let's just prepare 4 variables. So self dot left and self dot right. So as for the left, we're going to choose the minimum value. So we're going to choose the maximum for the left. So the maximum of left is going to be the column c minus 1, and for right it's going to be 0, because for the right definitely we're going to choose the maximum. And similarly for the self dot, let me prepare up and self dot maybe down, top and bottom, maybe top and bottom, top and self dot bottom. And similarly the top gonna be r minus 1 and the bottom gonna be 0, because for the bottom we're gonna choose the maximum value. Now let me just prepare the final result first. So it's going to be the self dot right minus the self dot left plus 1 times self dot bottom minus self dot top plus 1. So this is going to be the final result. Now let's just update it from here. So from here we're going to update it. Let me just copy and paste. We just need to update 4 variables. So we're going to update those 4 variables. So for the left, as I said before, we're going to choose the minimum value. So self dot left with the current value, it's going to be the column. And similarly for the right. Let me just copy, and here going to be the max with the self dot right and with the column. And for the top and bottom, let me copy and paste. So the top gonna be this one, and the bottom gonna be this one. Let me first copy it. So for the top, here gonna be the top, and this one gonna be the R, because for the top it's gonna be the row. Here gonna be R, and here gonna be the bottom. So I think that's all about it. Basically, it is just a DFS. And if we are writing like this, definitely this is going to be a medium problem, because we just used a little bit mathematics skills to find the smallest rectangle. For finding the smallest rectangle, we just need to find the most left area and most right area, most top area and most bottom area. And then we can use the coordinate system to find where it is. And finally, we're going to use a mathematical formula to get the rectangle area. Now let me just run it to check if it works. Now as you can see, it works. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases, and definitely the time complexity gonna be O with B. B means black areas. Definitely it's gonna be less than O m times N. And the space complexity gonna be let me check the space. Did we use any space? So here we use 4 variables, and here RC, so that is okay. We use this DFS function, so the space complexity gonna also the space complexity will also be less than OM times SM times so it's gonna also be less than that. So the space complexity, we just ignore the image because we didn't do anything for the image. So the space complexity gonna be like SB. B means the black areas. So this is gonna be the space complexity, and the time complexity gonna be OB. B means the number of black cells. I think that's all about it. Thanks for watching.